The next part of the question asks us, what is the scale factor of the drawings? I'll briefly talk about what that means. Anytime you're building a building, an architect will have a set of blueprints or plans for the building, which I'm going to represent with this little blue rectangle. On that blueprint, he'll have a picture of the building that he's trying to draw. However, the space that the building takes up on the drawing is going to be different from the size of the building in real life. Buildings in real life, of course, will be much, much larger. We can say that the shape on the blueprint and the shape of the actual building are similar. And because those are similar shapes, that means the sides will have the same ratio. We found previously that the height of the actual building will be either 225 inches or 18.75 feet if you want to express it in feet. I'm going to use the 225 inches. We'll write that as the height of our building, and I'll mark it here with this line. However, on the blueprints, the size of that side is much smaller, of course, because it has to fit on the paper. That's 12.5 inches tall. However, since the shapes are similar, we can find a ratio between those sides. Before we find the ratio, there are a few things we need to check. First, make sure the sides are actually in the same position and are similar. We can see, since we're looking at the height, 225 inches and 12.5 inches, that these will be the same side. They'll be similar. Second, we need to make sure that the sides are in the same units. Notice that on our blueprints, our units are in inches. However, the height of the building could have been in feet or inches. We want to make sure that we choose the inches because that is the same unit as what's on the blueprint. This will help us find the ratio better. If you have a mismatch in units, that's going to give you the wrong answer. Third, we'll have to make sure that our numbers are in decimal form, not fraction form. Notice that we do have a problem there because our blueprints are in fraction inches, and so we're going to need to rewrite those as a decimal. Note that we do have a mixed number in that we have 12.5. That 12.5 actually has an invisible plus sign in between the 12 and the 1/2. So rather than saying 12.5, we'll instead write 12 plus 1/2. Notice that 12 is a whole number, and we can go to the calculator and change 1/2 into a pure decimal. Let's go to the calculator now, and let's enter that 1/2. When we say 1 divided by 2 in our calculator and press equals, we get 0.5. Therefore, we'll write this again, but instead of writing 1/2, we'll write 0.5. Since we have a whole number, 12, and 0.5, a pure decimal, we can just put those together and say that our number of inches on the blueprint is 12.5. We'll make that replacement in our drawing. Now to find our scale factor, we'll take our actual size divided by our blueprint size. Our actual size was 225 inches. Our blueprint size was 12.5 inches. Let's go to the calculator and make that division. We enter 225, divide, and then say 12.5. When we press enter, we get 18. This will be our scale factor. Therefore, for every piece of this shape, the scale factor is 18. If we multiply the blueprint by 18, we'll get the actual size. Now that we know the scale factor, we can find the length of any side on that shape. We'll do an example of that on the next slide. Now we're told that on the same blueprint, using the same scale factor, the width of the building is 48 inches. How wide is the actual building in feet? Let's draw the blueprint of that building. And let's mark that the width is 48 inches. We'll also draw a larger building to represent the actual building. We don't know how wide the actual building is, so we'll mark this with an X. Now we don't have any other sides, but we do have a scale factor of 18. This tells us that the blueprint times 18 will give the actual. We do know what the blueprint is. That's 48 inches. I'll put a check mark next to that. And so we'll say that for the actual unknown side of the building, we'll take that blueprint 48, and then we'll multiply that times 18, and that will give us the actual length in inches. The reason why it's in inches is because the blueprint's in inches. Let's go to the calculator and find what that is. Notice we have our 18 already stored in the calculator, so we'll now just say times 48. Press enter, and we get 864 inches. This will be the actual building's length in inches, but notice the question did not ask us for inches. It asked us for feet. So now let's change the inches back to feet. Since 1 foot is divided into 12 inches, if we're going inches to feet, that means we're going to divide by 12. We'll take our 864 from the previous step, and then when we divide by 12, we will get feet. Let's go back to our calculator and do the division. We have 864 already stored in our calculator, and so we'll say divide, and then 12, and press enter. We end up with 72 feet. We'll write that as our final answer. The 48 inches on the blueprint gave us 72 feet in real life.